We'll start with example 4, and this is still on page 111, and we'll need a graph on this example. So if you can put the graph at the bottom of your page someplace, or maybe if we just write down the function first, you could just put the graph right underneath the function. So here's our function. We have a piecewise function. This piecewise function has two pieces to it. The top piece is f of x is equal to 3, and that happens when x is less than or equal to 3. And the bottom function is 2x minus 3 if x is greater than 3. And we're going to graph this. So the first thing I want to do is make a table. And we're going to choose x values. The place where where we choose which piece of the function we're using, that splitting point is this 3. So let's choose 3 numbers smaller than 3. And it's good to choose a negative number, at least one. So let's choose -1, 0, 1, and I'm going to put 3 here. And then because 3 is our splitting point, we'll just call it, I'm going to start with 3 again for the top, for this other function, and because it says bigger than 3, I'm going to use 3 other numbers bigger than 3. So if we're looking at the numbers that are smaller than 3, this tells us that it's just 3 every time. So if x is -1, I get 3. If x is 0, I get 3. If x is 1, I get 3. And if x is 3, because it says equal to, I get 3. So now let's look at the ones that are bigger than 3. So notice this one doesn't say equal to, it's just bigger than 3. So let's kind of put this point in a circle because it's not really part of our graph, but we're going to need it to graph. So we'll put 3 into the problem. 2 times 3 minus 3. 2 times 3 is 6 minus 3 is 3. And then we'll put 4 in. 2 times 4 is 8 minus 3. And then we'll put 5 in. 2 times 5 is 10 minus 3. And then we'll put 6 in. 2 times 6 is 12 minus 3. So we're going to graph these. Now because this one's not really part of our graph, this one will have an open circle. And because this one is part of our graph, because of this equal to 3, this dot will have a closed circle. So now let's graph those points. Our first point was -1, 3. So we'll put a dot right there. And then we had 0, 3. So it's a dot right there. And then we had 1, 3. It's a dot right here. And then 3, 3 is a dot right here. So remember this one said equal to 3, so it's a filled in dot, and we want all the numbers smaller than, so you can see what we're getting is this line that goes straight across. So now let's look at the other points. We started with 3, 3, and that was an open circle. Okay, and we can see that open circle is filled in with orange. That's because these two end up matching and lining up in the same spot, but they don't always. And then the open circle and the closed circle becomes really important. 4, 5 is our next one. And then 5, 7. And then 6, 9. So you can see we're going to start with that open circle, and because we're going greater than, we're going to the right, and we end up with this. And this is the graph of this piecewise function. There's a piece in orange, that's the top piece for all the x values that are less than or equal to 3. And then there's a piece to the right, the blue piece, that's the bottom piece of our function for all x values greater than or 3. Let's do another problem. We'll start on page 112. So, like I said, we'll be on page 112. This will be our last example. So we'll get our function written down first. So here's our function. F of x is equal to negative x plus 1 if x is less than 1, and x if x is greater than 1. So this time, 1 is our kind of changing point. So we'll make our first table, and we want numbers less than 1. So let's do negative 2, negative 1, 0, and then we're going to include 1. Now, remember that this doesn't say equal to here, so we're going to kind of put this point in a circle because it's not really part of that graph, but we're going to need it. And then we'll start the next table with 1 again. We're always using this splitting point in both tables. This one's equal to, so this one's going to be included. So this is going to be our filled in dot, and this is going to be an open dot. And then we're going to keep going with numbers bigger than 1. So let's say 2, 3, 4. So we'll start with the top row here. So this would be negative and then negative 2 plus 1, because there's a negative in the formula, and then we're sticking in negative 2. So it becomes positive 2 plus 1 is 3, and then negative 1 plus 1, which is positive 1 plus 1, which is 2. And then 0 plus 1 is 1. And then negative, and then a 1 plus 1 gives me 0. So again, this is going to be my open dot. I don't want you to think that's a 0. And let's look at the next one. The next one says whatever x is, so y is the same thing. So if x is 1, y is 1. If x is 2, then I stick 2 in here and I get 2. If x is 3, I stick 3 in here and I get 3. When x is 4, I stick 4 in there and I get 4. So that gives us points, and we'll graph those points. So we'll start with the ones I was writing in purple first. So that'd be negative 2, 3 is a point. Negative 1, 2 is a point. 0, 1 is a point. And then 1, 0 we're using as a point, but it's an open circle because we didn't have the equal to. So this is for x values that are less than 1. Less than 1 means to the left. So it would be a line that goes like that. Then we start with our other points, and we start with the point 1, 1. Now this said less than or greater than or equal to 1, so this is a filled in dot. And this is what I was saying before, that filled in dot and that open dot don't always match up, so it's really important that you get the filled in dot, which one's filled in and which one's open. Then the next one would be 2, 2. The next one would be 3, 3. And the next one's 4, 4. And we're going bigger than 1, so we're going to the right with this, so our line would go this way. You're never going to have lines on top of each other because it's a function, so it still has to pass the vertical line test. Remember back from chapter 1, like the second day of class, we talked about the vertical line test, and every function has to pass that. So you'll never have a graph on this side and then another graph on this side. That can't work because those are on top of each other, and you'll never have graphs on top of each other. So wherever that division point is, in this case that 1, that splits our graph, and you're going to have one graph to the left of it and one graph to the right of it.